Okay, so for this part, we are going to be solving the quadratic equation by the graphical method. By the time you hit this part, you should have come across solving the quadratic by factorization, by quadratic formula, by complete square. So we can also get the same answer by drawing graph. So when we say we draw graph, that means we use a graph paper to draw graph. So drawing graph and sketch graph are two different things. Drawing graph means you draw it on graph paper. Sketch graph is just you can do it on a normal paper. Okay, so in this situation, right, in this part, in this method, we are drawing the graph on graph paper, we get the answers. Okay, so you need some basic idea first, or else, right, a lot of students, even if they draw the graph, they couldn't get the answer. So if you would like to solve a quadratic equation, so how are you going to, so this is the equation that you will need to solve. So how can you find it from the graph? You're going to find it from the graph. Okay, so you make this part into a graph. So you make that part into a graph. And then the answers is actually the x coordinate on the x-axis. So in another word, it is the x-intercept. So the x-intercept of the graph will be the answer to the quadratic equation. So the x-intercept of that graph will be the answer to that quadratic equation. So for example, let's take a look at this. Okay, so in example 3, your job is to solve that quadratic equation. So I'm going to solve the quadratic equation. Feel free to use any method that you like. So I'm going to do it by simple factorization. I'm just going to be taking out the common factor. And then my first bracket is 0. My second bracket is also 0. So you punch calculator, you will get a 2. So we solve it, okay, whichever method that you want. Okay, so in part B, you realize that we have a graph. And this graph is exactly this equation. So where is the x coordinate of the intersection with the x-axis? So they are asking you what is the x-intercept? So the x-intercept should be the calculated answers here. So it should be a 0 here, and it should be a 2 here. So the instruction is to write down. That means actually you do not need to do any working. You just need to understand that the x-intercept is going to reflect the same answer. So the answer will be x equal to 2 and x equal to 0. So if you solve it by any method, that the answer that you solve it by any method will be found on the x-axis in the graph. So it should be the same answer. Okay, so this one is just a generic idea first. So let's really go about the actual drawing. So in example 4, you have a typical equation. You get a typical graph. So you need to complete the table. So this is like your set 2 work. So you just have to remember when you're completing in the table. So for example, you're going to be completing with this. When you punch in the calculator, you must remember the bracket. If you punch and you forgot to give the bracket, then you will get wrong answer. Okay, so like make sure you remember to input the bracket. Okay, then you fill up accordingly. So I'm assuming you can fill up. And then we're supposed to draw the graph. So this is the part where you're supposed to draw it on graph paper. So, okay, I take it as you are able to fill it up, and then you draw it on the graph paper. So I'm also taking it as you know how to do the graph part. Then after the graph, we actually need to solve the equation. So this equation is already the graph. So where can you find the answer? You will find the answer on the x-axis. So you will find the answer on the x-axis. So the answer according to the graph will be minus 0.5 and x equal to 1. So there are two answers. So it comes from the x-intercept. Okay, in the last part, we actually want to verify. So what is your understanding of verifying? Okay, that means, right, I'm going to be doing the same questions, but then I'm going to be using the quadratic formula. So I'm going to show my quadratic formula. And I'm expecting that I should get the same answer as the x-intercept. So that is the idea of verifying. So when we want to verify something, it's like to double confirm. So I'm going to try the quadratic method. So I should be getting two answers. Okay, you punch your calculator. So you will get a 1 here. Okay, 1 minus 3 is minus 2. So you get a minus 0.5. So you actually get the same answer. So you check out, you actually gotten the same answer. So the quadratic formula give you this answer. The x-axis from the graph also give you the same answer. So if you want to solve a quadratic equation from the graphical method, you just draw out the graph and the answer can be found on the x-intercept. Okay, so let's explore another question. So this one, they kind of draw for you. Okay, and we are supposed to, okay, for part A, right, they wanted the line of equation. So that is like a set 2 work. But typically, it will be always asked about line of equation symmetry during O level. So do you still remember the line of symmetry? So typically, the line of symmetry, right, should be in between the x-intercept, or rather the highest point. So a lot of people, they will tend to forget the line of symmetry in this case is a vertical line. So the line of symmetry is a vertical line. And if you look, it should be x equal to minus 0.5. So the equation of the line of symmetry, that means the name of the line of symmetry is x equal to minus 0.5. You cannot give a minus 0.5. If you just give the minus 0.5, you will get no mark. It is just a value to me if you have just given a x, if you just given a minus 0.5. So we wanted an equation. A vertical line equation is always x equal to the number. Okay, so I'm going to use the graph to solve. Okay, this one is a little bit challenging. Okay, this one is a little bit challenging. Okay, if you take a look here, this is my graph. So this is my graph. But this is the equation. So currently it doesn't match. So currently it doesn't match the graph. So the equation that you solve must match the graph. So how am I going to match the graph? So this part is difficult. So if I want to match the graph, I got to manipulate. So I'm trying to manipulate the negative. So I multiply by -1 on both sides. Okay, after you multiply by -1, you realize that the equation is looking a little bit like the graph. The equation is looking a little bit like the graph, but the number doesn't match. So this part doesn't match. So what I'm going to do will be, so there is a trick that I will always do. So this part is looking like the graph. I shift the number over. So I shift the number over. Okay. In order to achieve the graph, I need a +2. So what I'm going to do is, I'm going to +2 on both sides. So I'm going to do a +2 on both sides. So after I do the +2 on both sides, this will be my graph. My graph will be equal to a -2. And your graph is a Y. So this is a horizontal line. So I'm going to solve the equation by adding a horizontal line and I will read to get the solution. So I'll add the horizontal line. So the two solution will be -2.5 and 1.5. So this will be the solution for this equation. But I got it from the graph. I try to manipulate the equation to match the graph. Okay, but my solution doesn't come from the x-intercept. My solution comes from adding the horizontal line and I get the intersection with the horizontal line. Okay, so this is a challenging part. So this is the part that you will be revisiting, in fact, in the topic, in another topic called graphical solution. Okay, so the equation that you want to solve, so if you want to solve an equation, you must have that graph. But if you don't have that graph, then you need to manipulate the equation so that eventually you look like the graph. Then you make use of the graph to solve. Okay, so this one is an asterisk example. So you will have more of this to come. Generically, if it's not so difficult, so the equation that you want to solve is the same graph, then you just get it from the x-intercept. Okay, this is a more difficult version. So that is the graphical method of a quadratic equation.